Okay, welcome to C++ Club. This is meeting 154, and today is the 30th of September 2022. We'll start with CPP.conf keynote by Bjarne. The topic this time was C++ in constrained environments, and I thought I'd quickly summarize the talk. The embedded and other constrained environments have been not covered enough in the mainstream C++. Well, I guess there were quite a few presentations, but if people don't work in that area, they might not be aware of the constraints that the embedded developers face. So I guess Bjarne decided to address that and all the other problems that stem from the constraints. He said that many systems have constraints that dominate the design, like limited memory, limited CPU speed, extreme reliability requirements, limited latency, zero or limited downtime, and long life, like decades long. But when teaching C++, these constraints are usually ignored. The focus on constrained environments is at reliability, because like a space probe is not easy to repair. Dependability, a car on a bank or a piece of medical hardware where failure can be disastrous. Resource constraints, small relative to the task they handle, a surge protector or a smartwatch. And messy problems, like hardware problems and unusual attached devices. And also maintainability, which is the lifetime of those devices can be measured in decades. He said that there is no silver bullet. We need to use several approaches in larger systems, adapted for those systems. You can target C++20, but in many cases, your code has to be usable starting from C++11. And some people are unfortunately stuck with C++98. And Bjarne said about it that really shouldn't happen these days. We know it does happen, unfortunately. He had a slide on common misconceptions, and the bullets were learning C is a prerequisite for learning C++, which is not true for modern C++, like Kate Gregory said many times. It's useful to know, I mean, the concept of pointers is definitely useful to know, but it's not what modern C++ teaching should probably start with. Another bullet point was C is the best C++ subset for constrained systems, which is not true anymore. You can use more features of C++ than just C-like code. Another one was good C++ relies on a lot of dynamic memory use and large class hierarchies with runtime resolution of all function calls. That hasn't been true for a long time. Of course, as they say, you can write Java in any programming language. And much of the code I see every day uses shared pointers everywhere. But the guideline I saw was that you should keep your hierarchies shallow in C++. I remember when I started working with .NET and C#, the class hierarchies there were like 30 level deep, especially in WPF, if anyone remembers various controls and all their hierarchies. That's not the C++ way. Another misconception, to be reliable, code must be littered with runtime tests. He says that's not true, and you should always prefer like compile time tests as much as possible, and compile time verification, static analysis and such. And the last point is probably the most contentious lately, was embedded systems must avoid exceptions. To which Bjarne said it's true only for some tiny systems and some hard real-time systems. He said that language serves the programmer, not the other way around. So you should use as many new features as it is sensible for your environment. Of course, your compiler that you're using for a particular embedded system might not support the latest C++ features, but you should strive for using more of those as much as it makes sense for you. Regarding optimization, he said, don't optimize every line of code. Measure, then tune. C and C++ map directly to hardware thanks to the genius of Dennis Ritchie. And C++ machine is itself an abstraction. You should make your every construct checkable so that rules are expressed in the code. Static checking can be difficult or impossible, and runtime checking can be expensive. You should try using immutable data as much as possible, which protects against data races. You should definitely initialize your data. C++ strives for zero overhead. You should leave no room below C++. But that doesn't mean zero cost. You pay for what you use. For resource management, use RAAI. You should move work from runtime to compile time, if you can. And with modern C++, you can avoid falling back to C-style C++ and unsafe practices. If you attempt to create a safe subset of C++, like many embedded shops do, I guess, or especially game programmers like to do, in that case, you end up having to write more code that has to be correct because you can't use all the available language facilities. To avoid using unsafe techniques, you can extend the language using STL and GSL, guideline support library from Microsoft. And you should not aim to be stuck with classic non-modern C++. If you remember, we discussed at some point a GitHub repository which is called, I forget, traditional C++, or no, it was like something like, it was dedicated to guidelines for writing C-like C++, C with classes style C++. And I think the creator of that repository was a game developer. Of course, don't do that. Now, the next series of slides was about error handling, and I especially liked this illustration, which is really creepy and scary. Quote, "Don't even dream of a single style of error handling for everyone supported by a single language construct." End quote. So you can use exceptions and you can use return codes. Whatever makes sense for you. But sometimes you don't have an alternative, like you would only use exceptions to report errors from in constructors, operators, and callbacks. Of course, there's like two-stage initialization that some people use where if the constructor fails and they can't throw, they set a flag. That's suboptimal. You end up with a half-constructed object. Return codes, use them only in hard real-time code when there are latency guarantees. If you can use crash terminate, then that's, I guess, universal, but not everyone can use it. I mean, if your game or a GUI program or an automotive display suddenly crashes and restarts, that's not ideal. Actually, I remember someone was presenting a talk about a Mars rover, and they said that if anything bad happens, the default, I think, is to just terminate and restart the entire system, just to be sure. Regarding exceptions, Bjarne said, exceptions are not zero overhead, but neither are other error handling strategies. They can be zero overhead on the happy path. That's what exceptions are, I think, on 64-bit AVI. They are pretty much zero overhead on the happy path.
Yes, it's really almost impossible to measure on most compilers the effect of exceptions on the happy path. And obviously, when people want to demonstrate that there is a cost to exception, they put the exceptions in logic that drives some sort of error handling code, and obviously then you can measure the stack unwinding.
Yes. On the other hand, use exception handling sensibly. Don't litter your code with try-catch. That kind of defies the purpose. Handle exceptions at the point where handling them makes sense. And don't use exceptions for common failures that can be handled locally and are expected, I guess. I have the next slide, which is return an error indicator, an error code, when a failure is normal and expected, or an immediate caller can reasonably be expected to handle the failure, or a system has so little memory that the runtime support for exceptions would crowd out essential functionality, or the code is already a mess of pointers with no implicit resource release, C-style, or an error happens in one of a set of parallel tasks and we need to know which task failed. Don't even try to percolate every error to a handler. It's expensive, it simulates exception handling, and is extremely hard to get completely right. That was it for the error handling part. Bjarne followed with his dreams of the future. Regarding the ISO standard, he hopes for executors, a more comprehensive model of concurrency, pattern matching, simple, uniform, type-safe, and efficient model of selection, static reflection, yes, a simple way of generating code based on already defined code, better library support for coroutines, make the preprocessor redundant, I think we're getting there, and integrated language support for static analysis, like safety guarantees. Stability and compatibility is a crucial feature. And performance, no bloat in the implementation of language features and standard library components. He continued with this: not all needed major new facilities are language and library facilities. For that we need a package mechanism and a repository of packages. These are common pain points, like whenever anyone asks on Reddit, what are your pain points in C++? Almost the first answer is always package management. He also said static analyzers with support for profiles of specified language guarantees, like guarantee type safety. Static analysis supporting code transformation, like upgrading to use newer features and techniques. That definitely reminds me of Carbon goals. And also, if you remember, Google has a library called Abseil, which they aimed for people to use at master, at like the latest tip of the code. And they promised to provide a software tool that would allow people to migrate to the latest code if need be. So that definitely rings a bell here. Of course, that's never going to be standardized, but still we need it. And more C++ core guidelines, for example, in the concurrency area.
We need more people to adopt the ones that are there already. We need advertisements for the core guidelines. They're not as well known as they should be.
That is very true. Clang Tidy has a set of checks for the guidelines, I think. And now the modern Visual Studio versions, I think starting with 17 even, had a guidelines checker. But I think
Visual Studio has always been up there, because Herb Sutter is always there pushing for them.
Yes.
And they got that going for it. Visual Studio is very good at checking those from the very early start.
Yeah. So, yeah, that was it. A good presentation, as usual. And I just pre-ordered my copy of the Tour of C++. the new edition, the third edition aimed for C++20. And maybe if Biana visits London at some point, I'll get it signed. Right. On to the next big topic today. Herb Sutter's keynote. Can C++ be 10 times simpler and safer? That's a big one. Basically, this is Herb Sutter's personal C++ evolution experiment. These are...
one of the many.
Indeed. These seem to be popular lately. This one has some distinct goals compared with others. He says, the goal is to refresh C++ itself, not invent a new language. His main idea is apply zero overhead principle to backward compatibility. Pay only if you use it. Second syntax for C++. He said, if it doesn't hurt a little, is it really C++? And then proceeded to try to remove the pain points. Basically, he implemented his own major papers, metaclasses. Well, that's coming. It's not implemented yet, but I think his goal is to implement metaclasses in Cpp2. Value exceptions, also not ready. Parameter passing is there, and is as pattern matching is partially there. He started implementing it. Well, I guess that's one way of getting your paper into C++, kind of. This whole...
What if he doesn't get his paper eventually into C++? Is he gonna fork as well? He's already on the way. He still claims he wants this to be a continuation of C++, but effectively he's diverging already. I don't know.
He can always keep this as a running experiment. I mean, he doesn't make any promises, so I guess people will be using it even if it doesn't get standardized or anything.
I think he certainly hopes that it's going to take off. He keeps saying in the presentation, "Oh, this is an experiment. It's going to fail, or whatever." He's playing it very cautiously, but
yes.
I think it's pretty obvious that he wants this to succeed, as normally people would. And at this point, what if he doesn't get this thing to actually eventually get merged back into the standard one way or another, and which I don't think is gonna actually be. I don't know. We already got Alexandrescu trying to defect, and going into D.
Exactly. All good questions, and there's no way to tell. So far, it looks like he wants to keep on using C++ in whichever form. So that's probably a good sign. But yeah, anything can happen if he doesn't get his way. I mean, the presentations about his metaclasses and value exceptions were quite a while ago, and the papers are not progressing in any meaningful way. So I guess he's trying something else now. To me, it distinctly feels like TypeScript versus JavaScript.
I think that's an apt comparison. Well, TypeScript was definitely improvement over JavaScript, and everybody loved it. So I think that's what he would like to see as a response.
But
and
people
to an extent, I mean, it makes sense, that people try.
Yeah, and people still use both JavaScript and TypeScript.
Yeah, but at least you can see, you can say, okay, TypeScript is probably better, in many aspects. You're still gonna have JavaScript laying around. You just introduced a new dialect in a way, which is a problem. But maybe you did move into the right direction, and then maybe you could envision people moving there. Here, I'm not sure. Also, I don't know, if this actually solves the problems that it's trying to accomplish with this. So I don't know.
Yeah. JavaScript ended up like sort of an assembler, a runtime for some uses, like WASM, for example, WebAssembly, right? It compiles to JavaScript, as far as I know, right? Or
so.
is there is a native component to it, I think, but by default, I think it compiles to JavaScript. So what if we end up with C++ being sort of an assembler language that no one uses directly?
And one layer down. It's like an intermediate representation before the intermediate representation.
Something like another level of interaction, which apparently solves all problems except one.
I don't know.
I know there's a language called Yact, which was created by the author of Serenity OS, which was written from scratch in C++. But Yact is their goal for the official main language for Serenity OS. And at the moment, I think it compiles to C++, or it used to compile to C++ in the beginning. So yeah, C++ is already kind of an intermediate language. And lots of code generation tools also generate C++. And now we have one more of those.
At least this one hopes to generate good looking and readable C++, which,
yeah, that's
that going for it.
Yes, that definitely is a good thing. So Herb said, what would Bjarne do? And he meant 40 years ago. 40 years ago, Bjarne wrote C-front, which translated C++ code to C. And so Herb Satter now wrote Cpp2, which translates C++, or Cpp2, like he calls it, to C. To C++, sorry. So yeah, I picked some of the slides to illustrate his syntax experiments. Declaration syntax in Cpp2 is left to right in the form of name, type equals value. Definitely reminds me of Scala. Another slide with some sample Cpp2 code. The Cpp2 utility can use pure mode, which means that there are lots of deprecated stuff that's not supported out of the box, like macros, the entire preprocessor. Stud module is implicitly imported under the pure mode, so you can use the standard library right away without any additional preparation. It's a modules first, fast build, strong ODR language extension, I guess. He implemented his own paper. Parameter passing paper is about marking parameters with like in-out and other annotations. He implemented an underscore wildcard and implicit template arguments. And also he implemented optional return for single expression function. So that leads nicely to the shorthand lambda syntax, which many people still want for C++, but it's probably not going to happen. Next slide was his medium-term plans. He wants to complete the basic language, explicit template parameter lists that would support concepts. Classes are not currently supported in Cpp2, so classes are planned, including user-defined types, including defaults, explicit constructors, type invariants, completing contracts, and some unification of operators. I guess that's deducing this. Also planned are reflection, generation, code generation, and meta classes, and also lightweight exceptions using stud error condition, like his paper proposes. This is a slide with the problems that Cpp2 solves compared with Cpp1, as Herb calls the standard C++. And it's a lot to read. I'll have this screenshot in the notes. So to summarize, in Cpp2, core guidelines are the defaults, left-to-right declarations of the form name, type equals value. References are not supported. Herb really doesn't like them. he says they were introduced for parameter passing only. Implicit imported module underscore wildcard. Lambda is declared the same way as a function, but omits the name, and that with optional return leads to the short lambda syntax.
I don't know, this fact about the reference, I don't see the problem with that, but the problem with his approach is that you don't have references explicitly, but implicitly you still do. And this time you need to know which arguments are going to be passed by references and which are not going to be passed by. It's a bit like any, like Python or other similar languages. Some objects are going to be passed by value, some objects are going to be passed by reference, and now you need to know. So you still need to have the concept in your head. It's not as explicit as it would have been, which I think is overall not as good.
Exactly. If you remember Carbon, they also use some magic and say the compiler will decide how to pass parameters. But yeah, I agree with you. In the end, it's good to know, or maybe it's even essential to know what kind of parameter type you have, even if it's hidden by a compiler magic or this CPP front.
Yeah, I think most C++ developers want to have control over things. They like knowing exactly what's going on.
Remember the discussions when the concepts were introduced?
Mm-hmm.
We can't have short concept syntax because we need to know what the type is.
Yes.
And now suddenly we don't need to do that.
That's, I don't know if it's going to be swallowed by the same people. I don't know.
Yes, exactly.
But I think overall this approach, even if he made a lot of good decisions, and maybe I'm not discussing this, but how does he address the problem of evolution? When things need to change again, is he gonna do Cpp2? Is he gonna break the ABI? Did he address this problem? I don't think so.
No, I think it's just about the syntax. He doesn't. He's not going to break ABI, I think.
Yeah, but even if he wants to break it again, like he's going to change the syntax again, he's going to do it in another 40 years only, or maybe in 10 years he wants to change something else, then what then?
Yes. Good point. It's his personal experiment, so anything can happen.
Yeah, but if he went his way, it wouldn't be his personal experiment, so then we still have to solve the problem, how to do any sorts of evolution,
Well, the good part, as you said, was that CPP front generates readable C++ code. So in the worst case, it can just be like materialized as C++ code, and then, I don't know. I guess we'll see how this takes off. In pure mode, there is no preprocessor. What's interesting is order-independent syntax. So that means Cpp2 doesn't need forward declarations, and it's implemented by writing out forward declarations automatically in the generated C++.
Of course. I mean, that's nice. Nobody wants to write forward declarations.
That's true.
But yes, but under the hood is just, yes,
there's no magic.
Write all the forward declarations anyway.
One thing I was curious to see was the operator : equals. Remember Pascal?
I don't.
He didn't mention it explicitly, but from the source code, I can deduce that it's for automatically defined variables. So you, like in Python, you write a variable name, then you write : equals func, and that at the same time declares and initializes the local variable with the return value. I think that's something like that. Universal function call syntax. This means that free functions can be called as member functions. So for example, you can call vector.size to get a signed version of size instead of going size vector.
This is, this he claims, that it is also for tooling, so that you can do object dot. And, I think it's a noble pursuit, but on the other hand, this is going to confuse the humans. I don't know, because I would expect this function to be defined in the class of the object. But then again, I don't know.
Yeah.
Maybe we only need the toolings, but
Thing is, if you decide to use this in your project, and you also decide to migrate your project gradually, and you have mixed code, Cpp2 and C++, your brain's going to go into overdrive, and there'll be lots of confusion. I mean, you'll want to write C++ as Cpp2, and I don't know. We'll see, I guess. All typecasts in Cpp2 are done via as, which is part of the pattern matching proposal. Yeah, I guess that's not bad. Union is not supported. Use variant. All variables are initialized before use. Null pointer is not supported. There is no pointer arithmetic. Delete and owning raw pointers are not supported. Unary operators are suffixes. That's really weird. When I saw this code, it looks really weird. To get an address, follow the expression with ampersand. So if you dereference a pointer, you write pointer variable star, and if you want to get an address, you write var ampersand. That's really weird. He did implement contracts. Good luck with that. That's going to change many times, I think, in the coming years.
Yes, what kind of contracts did he implement?
I think it's expected and expects and ensures, something
so
like
those
that.
ones that are kind of in the GSL, I think.
Yeah, you might be right. That's probably what he used. So regarding parameter passing, there are out parameters. Weren't they discouraged? Looks like a regression.
I think he kind of does mention that, if you don't have to use the out parameter, use the return, just return the value. I think somebody was asking, but if you do need to use the out parameter, then okay, there is the out label, which I think it's an okay idea.
There are other parameter annotations, which are copy, in, out, move, and forward. I think his idea is that these will make it simpler to reason about what happens with the argument passed into such a parameter. In parameters are automatically const, and you don't need to choose between passing by value or by reference. Yeah, we just discussed this. You probably won't be avoiding that. Variable capture using ampersand for lambdas, post conditions, and string interpolation. That's interesting. Regarding the generated C++ code, no discard attribute is the default. Okay, that's probably a good thing. Auto-generated forward declarations, like we said. It's human readable, which is good. And also, it uses namespace Cpp2, which contains all this magic. Regarding safety, Cpp2 compiler implements optional bound checking. You can run it with a special command line parameter, and it will add bound checking code to anything that can be bound checked, that has a pointer and size. So yeah, that is interesting. During the presentation, Matt Godbolt implemented CPP front support in Godbolt.
Was it during the presentation?
I mean, it was announced at the end of presentation, and there was probably more to that, but it was still very impressive. There are quite a few discussions on Reddit. I counted 6. Lots of duplicate threads. Let's do it! It's great! Though personally, I'm not sold on the unified declaration syntax, so it's like people will be happy with some aspects of it and not happy with others, and the cycle will repeat. Someone won't be happy with CPP2. It's the same with Carbon. They will submit a pull request, Herb will reject it, people will be unhappy and will, invent something else.
Vague and the aim is, let's make things better, let's break stuff. A lot of people will go for, the loadists will go for, yes, let's break the machine. Yeah. But then, when this becomes the standard, if it does, then people will just complain, in the same way that they complain with the current standard.
This one writes, I think this trend of experimental C++ replacements, val, carbon, CPP2, marks an inflection point. There are smart and talented people that couldn't push through ISO. They've had enough and are now looking elsewhere. Well, this is not looking completely elsewhere, but it's a point. And someone says, Herb Satter is chair of the ISO C++ committee, and he definitely will try to push this through the committee. Yeah. I'm sure some committee members look at this and say, we'll see about that. So yeah, this was another thread. Some people are not happy with the syntax. The syntax is just a syntax. So I'll have those links to the discussions in the show notes. But yeah, it's an interesting development, one of many. I hadn't looked at the Val language yet. I think it's by Doug Greger, who used to be on the committee.
Parent.
Sorry?
Is it also a Sean Parent experiment?
I don't know, maybe.
So
hang on. Yes, I think Doug Greger joined Adobe, so that must be...
That would make sense.
Yeah,
then,
yeah. So he went after... I think he was pushing for concepts, for the original concepts, the checked concept proposal, and when that didn't pass, he left C++ altogether and went to Apple to implement Swift. But now he's like back to C++ and maybe he's doing something like a new language replacement. So yes, it's very interesting. Let's briefly go to, this is the CPP front GitHub repository. There's lots of information and motivation and such. And there are already several contributors. So yeah. There was a new mailing in September, and I'll briefly go through some of the papers. There's quite a few at revision 0, which is always interesting to me. What do people propose that is completely new or mostly new? So this paper, function ref, a type erased callable reference by Vittorio Romeo and others. It looks like it's progressing pretty well, and I think it's targeted for C++ 26. And that would be a good thing to have for passing functions as parameters, because stat function is a bit too expensive.
This is basically how to avoid remembering how to define a type for a function.
Yeah.
Instead of going like, oh, let me Google again, where's the pointer, where is the brackets, and then you can go function ref as a type.
So the advantages of this is that callable objects supported by this, it takes any callable objects, regardless of whether they are constructible. Clean ownership semantics, it has reference semantics, minimal overhead, and that even enables modern compilers to perform tail call optimizations. So yeah, good thing. The next one I wanted to discuss was Proxy, a polymorphic programming library. And we looked at this before, and I was like, that's a nice experiment. And now I see that it's like at revision 9. And also, I learned recently that the author of the proposal works at Microsoft. So, that seems to be progressing. Maybe we even get it in 26. It's like static polymorphism, but avoiding CRTP, I guess. The next one was Universal Template Parameters by Mateusz Pusz, Gaspar Ajman, and others, and Karantan Jabot. It's at revision 3, and they say it's been completely rewritten. I just saw an email from the committee GitHub saying that more work on this should be encouraged. So I guess it's a good idea. This paper, it's a quote, this paper unifies the model of template parameters with the model for dependent tokens, types, values, templates, and at some point, hopefully concepts. This model is not uniform in C++23 because it lacks a way to treat all of the above uniformly, ironically denying the ability of generic code to treat itself generically. And so basically this introduces something called template auto, which I guess is magic. We'll see how this goes. Next one is standard secure networking. Oh, this is at revision 0, and the author is Niall Douglas, who did lots of work on the standard networking previously. So this is a proposal for standard secure networking based on the same concepts and idioms as his file handle and mapped file handle, which are part of his low-level file library. Judging by the examples, it's a pretty good proposal, makes writing like network code easier. But what caught my attention...
How does it address the problem of security fixes and patches? Does he cover that or not?
I hadn't read it in detail, so I don't know if he does. From the code examples, it's pretty straightforward to like read something from an HTTPS server. But what caught my attention was that he doesn't mince words about the executor's proposal. I think he might be biased, just a tad. He says, neither asynchronous nor coroutine I/O is proposed at this time, and therefore this proposal has no opinion which concerns P2300 state execution. I don't intend to propose any of that, like runtime pluggable, multiplexers settable per handle, and so on, something. Details. I don't intend, he says, to propose any of that for standardization because P2300 state execution lacks the extra lifecycle stage needed for efficient generic stacking of async layers, of which TLS over 1 million connections per kernel thread is a classic example. P2300 state execution lacks, in my opinion, the hard guarantee needed for efficient stacking of async layers, which is never possible dynamic memory allocation. To add relevant detail, myself and the authors of P2300 disagree about whether dynamic memory allocation can be given hard guarantees in the present P2300 design. I say no, they say yes, and I don't think we can reach reconciliation. Yeah. P2300 remains an insufficient subset of the P2052 proposal for our needs, in my opinion, as just aforementioned. Yeah.
Doesn't shy away from confrontation, this paper, I guess.
No. Yeah. So the next paper I wanted to look at was member visit and apply. This is just about making visit and apply member functions for a variant. The author is Barry Revzin, and he says the goal of this paper is to add member function versions simply for ergonomic reasons. The paper adds no new functionality that did not exist before. I guess we could live without it. Okay, existing and proposed, sometimes proposed looks a bit better. Fine.
Then, maybe one of those that could go through.
Yeah.
It's harmless enough.
So the next one is allowing allocation in static initialization. That's an interesting one that would presumably somehow magically allow you to allocate dynamic memory in context per functions and allow it to escape context per functions. That was entirely too much magic for me, so I didn't read the paper. But the concept is very interesting.
It's quite mysterious, I really want to know more about it too.
Yeah, that warrants a closer attention. And the last thing I wanted to show you was a link to GitHub of Steve Downey, who summarized C++23 status report for papers. So if you want to know what papers and proposals are in 23, that's a good source for you to read through. Right, I think that's it for today. I'll leave you with... Oh no, hang on. C++ Club got mentioned on Reddit in this question. Any good podcasts about C++? Thanks, Jay Karkinstall. And yes, that's going to be the tweet that ends today's meeting. Natalie Silvanovich writes, "Don't let the perfect be enemy of the good. Don't let the good be the enemy of the okay. Don't let the okay be the enemy of the kind of works, maybe." Right. Thank you very much all for coming, and I'll talk to you soon. Bye-bye.
Thank you, Gleb.
Thank you.